What is up, great people? Back again with another video. It's nosana, as some of you guys already know. In this video, I'm going to be doing a building and structural construction N5 or BSC N5 question on frame structures, right? So this is the question. All right, so in the previous video, I did an introduction and everything that you need to know on BSC N5 frame structures, right? If you haven't watched that video, please go and watch it and make sure that you have that grounding that you need to understand what is happening in this question, right? If you're new to my channel, please care to like, comment, share, and subscribe and be part of this awesome community. I also post grade 10, 11, and 12 pure maths and physical science lessons. And also I do offer lessons for grade 10 to grade 12 pure maths and physical science tuition, physical sciences, and also for BSC N5 lessons. So if you know anyone, whether it's your friend, cousin, brother, sister, whoever it is that needs help in maths, physics, or also BSc, right? Please care to to get in touch. I have my link in the YouTube description, so you can just get in touch and right. So thank you guys for that in advance. Right, so I'm not gonna waste much of your time in this question. Yeah, it was 8 marks, and so this is question one, right? Question one, right? It was 14 marks, and the first question of question one is 8 marks, and then the second question is the second question is 6 marks, right? So the question reads, it says that figure 1, which is that we see, it shows a loaded roof truss with 3 forces and a pitch of 30 degrees at both sides. So that means 30 degrees here and 30 degrees on this side here. So guys, what we know about properties of triangles is that if these two sides are the same, that means that if you divide, that means that the length of this side and the length of that side is also the same. Okay, right? So you just need to know that. What else are they saying? They are saying that this wind load, right, guys, this is what we call a wind load. We call this a wind load, right? So you need to know that that's a wind load, and also this 20 kilonewtons is a wind load, right? It's also a wind load, right? Wind load. And then this is just a force acting vertically downwards. Okay, so these would be your members, right, in your roof truss. These are most likely to be your struts or your rafters, right? The A and the C are most likely to be your rafters. And then this, how we read them, this would be FE, right? It will be FE, and this would be our tie beam. So in the previous video, I did explain what the different types of forces that the two types of members that we have here undergo. So we have we have a tie beam, and we have a strut. So a tie beam, right? A tie beam undergoes tension. And how do I know that? That's how we know. That's what we know. But how should you remember it? You should know that tie starts with T, so therefore it's tie beam, right? Tie beam, right? So if a tie beam undergoes tension, tension is usually pulling it outwards, right? Tension is like when you have a rope and you're pulling it both ways. So how do you oppose tension? Well, if you're pulling it both ways, to oppose tension, you need to be moving inwards, right? So this is how you indicate a beam that is undergoing tension. The arrows have to point inwards, right? The arrows have to point inwards. So this is how you discuss tension. The arrows point inwards. Forget about these ones that are going outwards, right? And compression, then if a beam is undergoing compression, then you should know that it is a strut, right? So compression is being pushed downwards, right? Compression is being pushed downwards. And if something is being pushed downwards, then what do you want to do? You want to pull it outwards, for it to be straight, right? You want to pull it outwards for it to be straight. So this is what we call a strut, right? We call this a strut. Okay, it's a strut, and what is happening? It is undergoing compression. So compression, you must know strut. Tension, right? Tension. if it's tension, you must know what? You must know it's a tie beam, right? So I'm just revising what I went through what I did in the previous video. So there's more to that video. You guys should check it out, right? So let me just erase everything that I have here, right? So I'm going to divide this video into two, right? Because of how long, basically the calculations themselves are not long. If you understand them, they're not long. It's the explaining that will make it long. So you need to watch each and every single second of this video, right? So you don't miss out on anything important. Guys, we have, right, so what we need here, what you will have to do when you're working with this, you will have to make a sketch of your own. But if the sketch in the book is big enough, or in the question, if the sketch in the question is big enough, then you can just use that. So what I did was I just read through that, right, separately, so that we can work with enough space. Okay, very thoughtful of me. Okay, so let me just let me just label this real quick. This will be the 24 kilonewtons, so it will be 24 kilonewtons there, and then here is the 20 kilonewtons, 20 kilonewtons. And then what else do we have? Okay, we have this wind load. Don't forget the wind load. Don't forget the wind load. Right. So here we have the wind load. It's 15 kilonewtons. It's 15 kilonewtons. Okay. That is the wind load. Okay, guys. 24, 20, and right. What before I move on? Okay, let me just mark these. So this is going to be our A. Okay, and this would be our C. This would be our F, and this is our E. And how you name or how you read this would be AF. This would be, okay, here they have B. They have B. Doubt we'll use it. We will ever use that. In this case, in this question. So this is A. So how you read each member, this would be AF. This would be FC or CF. CF. It will be CF, and then this would be EF. FE, I mean. A, B, C, D, E, F. So it will be EF. Right? You read it up in alphabetical order. Right. The next thing that you need to know is that you have, okay, so this is what you need to know about the wind loads. The wind loads are divided into two components. But before I can continue, I just need to indicate this. This is showing that it's a right angle, so that means that it's 90 degrees over here. Ne? It means that we have 90 degrees over there. Right, so if this is 9, okay. I'll show you, I will discuss that. So that means that it's 90 degrees, but we're not going to discuss that now. Okay, they told us that from there to there, it's how long? It's 4 meters. We are told that it's 4 meters, right? So if it's 4 meters, that means that we have 2 meters per side. If you divide it into two, that means this side is 2 meters and this side is 2 meters. Okay, but we will indicate that on this diagram here, on the load diagram. Okay, guys, now what I needed you to know is that if you have a wind load, it is divided into two components. If you have a hinge and a wind load, we divide them into two components, namely the vertical component and the horizontal component, right? You need to know that, right? You need to know that when it's a wind load or it's a hinge, right? Like this, they did say, sorry, I didn't read the full question, right? So the full question is saying, okay, if we look at the full question, we are being told that the roof truss is supported by a hinge at RL. So I'll mark the hinge RL, right? Let me just do that. The hinge, I'll say RL, right? And then the other side is the rollers, which is this here, is RR for rollers, I think. Okay, and the pitch is 30 degrees on each. That's how we got the 30 degrees. Now the question is asking us to calculate the magnitude and the directions of the reactions of the roof truss as shown. Okay, so what we're gonna do is come here on the drawing that I have for you guys. I'm zooming in. I should be zooming out. Okay, cool, like this. So this is the entire sketch. I didn't draw it to scale. This one, if you're using the graphical method, then scale is not that important. It's just important. Actually, it is important because sometimes you are not given this, that this and this side is 30, and you need to actually find the length manually. We will do more questions, and that's why you need to stick along so that you don't miss out. Okay, right. So here I am saying that this is R. because they say that there's a rollers here, there's a rollers or whatever that is, and this is RL because it's a hinge, right? Usually you can call it R hinge or RL, it's fine. Okay, finally, I said that you need to understand that the loads, right, the wind loads, they are divided into two, the vertical and horizontal. It's like what we were doing in grade 10. Remember vector diagrams, I think, right, in grade 10. Yes, vector diagrams, right? So they have the wind load and they are divided into two. There's a horizontal component and there's a vertical component. Okay, you need to know that. So each load has a vertical component and a horizontal component. So this here will be the vertical component. What am I doing? This will be the horizontal component and then this will be the vertical component. Okay, right. There's something I need to show you, right? But no, we'll get there. Okay, and then here what we're gonna do is okay, I'll show you just now. Okay, so here we have also a vertical and a horizontal component like this, and then here we also have a horizontal component like this. Okay, right, so this is for both the wind loads that we have in this. Same here with the hinge, but we will get to the hinge shortly. We'll discuss the hinge after this side here. So we also have the horizontal and the vertical component, right? So here's how you just need to memorize them, how to name them, right? So if it's vertical, right, anything vertical, let's just take a triangle, let's just take a triangle. This we can just make it 30 degrees, it's fine. And then what's happening here? We have the opposite, right? We have the opposite, and then the hypotenuse. So usually the hypotenuse is always the force, right? As you can see, this is 15 kilonewtons, so that would be the hypotenuse. It would be 15 kilonewtons, and then we will need to find this angle, by the way, this angle here. We will need to find it, this angle here, because this is a horizontal line, right? So this angle, we need to find it. They told us in the question that this was 90 degrees. So if it's 90 degrees, that means that 90 degrees over here, we'll need to, sum of angles in a straight line is 180. So to find out what angle that is, we'll just say 180 minus, what is this? 90 plus 20, which is 90 plus 30, which is 120. So it will be 60 degrees, guys. So this angle will be 60 degrees, okay? It will be 60 degrees. Guys, my focus is on naming the vertical and the horizontal component, okay? The opposite will be the vertical component, and then the adjacent will be the horizontal. Opposite will be the vertical component, and the adjacent will be the horizontal. So how you name it, to find out the opposite here, you just say sine, right? 30 degrees, which is the angle that I'm just assuming. I didn't look at that 60. That was before we calculate the 60. Is equal to opposite, right? Which should be the vertical component over the hypotenuse, which you would take there, right? So how you can just know that, you can just say everything that has to do with the vertical component, guys. Everything to do with vertical components, you can just treat it as if it's sine. Everything with the vertical component goes with sine. Okay, by that I mean the vertical component of this 15 would be 15 is our hypotenuse, right? So it will be 15 sine 60 degrees, right? 15 sine 60 degrees for the vertical component. Okay, but the other way that you can memorize it is just to know that any force that is going down, if it's from a wind load, the vertical component of a wind load, you can just take it as if it's sine. Just know that it's sine. Why do you say sine? You say sine the angle, and then you multiply it by the hypotenuse, right? Why? Because sine going down, you can just treat it that as if when you sin, you go down. Where when I grew up, I was being told that when you sin, you go to hell, and I saw that hell is a place that is down there where people burn, right? Until I grew up to find out that actually hell is in heaven, right? So guys, what I'm saying is that sin is going down, so that's how you should just memorize that. You'll take the angle and then multiply it with the hypotenuse and say sine. But then if it's the vertical horizontal, if it's the horizontal component, you will just say cos. You say 15 cos 60, which is the angle. Same here, same thing, that we will do the same thing over here, right? We'll do the same thing over here. We'll say the vertical will be 20, right? Sine or sin, okay, and then 30, yeah, and then the horizontal, again, I kept making this mistake. Here it will be 20 cos 30. Okay, so that's that. Okay, so enough talking. I hope you guys are getting me, right? This thing is not hard, guys. This thing is not hard. I just hope that you're getting me. Okay, so let me just show you guys that. So now we just need to put these forces on our load diagram, right? So these loads on our diagram. Okay, so the hinge, I'm gonna put it in at an angle. I'm just gonna do that. Okay, and now we need to put in the different forces that we have, right? First of all, I'm gonna start with, so we know that this is 40, sorry, not 40, it's 4 meters, right? We know it's 4 meters. We've been told that it's 4 meters. So if it's 4 meters, let's just assume this is the middle. If this is the middle, that means that this is 2 meters and this is 2 meters, right? 2 meters, 2 meters. And this is the 15 kilonewtons. So we're going to take the vertical component of the 15 kilonewtons. Okay. Okay, let me use a line. We're going to take the vertical component of the 15 kilonewtons. Okay, a black would do. The vertical component of the 15 kilonewtons, I'm going to do this. Okay, like that. And then also the vertical component of the 20, I think it's 24 kilonewtons, right? The vertical component of the 24 kilonewtons. I'm also going to take it and write it over there. Okay, what else? Okay, that is all for now. Yes, okay. So we just need to mark them. Actually, let's just mark them. So what is this going to be? This is going to be the vertical component of the 15, right? The vertical component of the 15 kilonewtons. So how do we name it? We will say 15 sine, okay, sorry for those guys. We will say it's 15 sine 60. That's the vertical component, right? We don't have a horizontal component over here. The reason for that, guys, the reason why we don't have a horizontal we have a horizontal component, but the height will be 0 because it's acting on the hinge, right? The height will be 0 because it's acting on the same point as our member here, as our second member, the other member, right? So we are going to indicate the okay, I think I should have just left that. We are going to indicate the horizontal component on our load diagram like that, okay? Right, we are going to indicate it and we're going to name it. It would be 15 cos 60. It'll be 15 cos 60 degrees. Ne? So this is for this. Okay, let me use a different color. I don't want you guys to get lost, so let me use a different color. Right. Okay, not bad. And I'm gonna name it 15 cos, right? 15 cos 60. Okay, 15 cos 60, and the distance from this to the point where it is acting is 0 meters. Right, is 0 meters, and we are going to move now. So this is the 24. This is going to be our 24 member, 24 kilonewtons. Right, it's 24 kilonewtons. But also on the 24 kilonewtons, what else do we have, guys? On the 24 kilonewtons, we also happen to have the 20 kilonewton. You can see it's acting on the same point. We also have a 20 kilonewton, right? We also have a 20 kilonewtons. But what I'm going to do is, on the 20 kilonewtons, I'll just leave it like that. And now I have I have a horizontal component of the 20 kilonewtons. The horizontal component, the vertical, sorry, let me speak of the vertical first. The vertical component is 20 sine 30. So I'll just write over here, I'll say and. Okay, so I'll say and. Okay, instead of that, let me write it below. Let me say and. Okay, and 20, right? 20 sine 30. Okay, that is the vertical component of the 20 kilonewtons. And I have a horizontal component. Okay, this is gonna be messy. Okay, it's gonna be messy. Let me erase this, guys. Let me erase this. and make it taller. I want to make it longer, not taller. Let me make it longer so that it can be seen properly, because I am seeing that there's a lot that is going on that point. So let me make it longer. Okay. Okay, now I'm even changing the color. Still gonna use black. Okay, I'm gonna make it longer. I mean, over here, excuse me for this, I just have to make it longer. There's no explanation. The reason for that is because of this. It's gonna collide, you know, because of how I'm drawing my thing. So the downward is going to be 24. Now let's go back. The downward will be 24 kilonewtons. Keep forgetting to change this. The downward will be 24 kilonewtons. 24 kilonewtons. Okay. Guys, this is not hard at all. It's not hard at all. You just need to practice. So now this is 20 kilonewtons, but there's also another force that is acting downwards, as I mentioned before, is the 20, right? I'll say and 20 sine 30, right? 20 sine 30, right? It's going to be 20 sine 30 because of this 30 here, right? It's in the same line, right? Same line. I'm sure I explained that. It's a collinear point, right? It's a collinear point, and it shares the same from here up until here. It's still 30 degrees, right? So we're gonna say 30 degrees there, okay? Because it's acting at a 30. If we draw a parallel line here, a line parallel to this, this would be 30. Okay, so yes, it's 30 degrees. Now I need to indicate now, guys, the horizontal component, right? The horizontal component of the 20 kilonewtons would be going somewhere there, right? And the horizontal component would be 20 cos, right? The horizontal component would be 20 cos. Different color. It will be 20. Hey, let me use black. The horizontal component would be 20 cos. Is it 30? Yes, 20 cos 30. So you need to be watching each and every second of this video so that you do not miss out. Okay. And now we need to find the distance. Like over here, we found the distance at the point that force was acting, to the horizontal member. This one here is acting on this point here, which is, now we need to find how high it is from the bottom, right? So what do we have to find out this? We know that this part is 2 meters, right? We have an angle 2 meters, and we're looking for this idea. So we can just say, let me just draw. You can even look at it from this side. This is also 2 meters, right? 2 meters. So you can just construct a triangle like that. Okay. And then you have 2 meters here, and then you have 30 there. And what are you looking for? You're looking for an opposite. You have an adjacent. So you say 10, 30 is equal to the opposite, which is the height, right? Is equal to the height. Let me just say opposite over adjacent. The adjacent is 2 meters. So you'll be 2 meters. So to find your height, you'll just say height, right? But the height, I'm gonna write it over here. I'm gonna say the height, I'll say it is 2, 10, 30. Okay. Now listen, you need to find the height at which the wind load is acting. That height, you will multiply it with the horizontal component, right? When you are calculating for your load, for your reactions, actually, when you're calculating for your reactions. So we have transferred everything on our on our load diagram, right? So now let me just write it down here. Let me just write down, this is going to be our RR, this is going to be our RR, and this will be our RL, or our R hinge. But this one also, guys, it is divided into two different force components, as I mentioned, horizontal and vertical components, right? But we will get to that. Right now, what we need is to calculate the reactions, right? We need to calculate the reactions. So let us do that. Okay, let us do that interesting calculation. Remember, right now we need to calculate the reactions. So we will take the moments, either the moments at RL or the moments at RR, okay, to calculate our reactions. We take the moments from a different from RL or RR. Okay, so I'm gonna take the moments at RH, right? I'll take the moments at RH. Okay, so I'll say moments at RH. Okay, so what is happening when I stand on RH? RH or RL? Let me just say RL. Moments at RL, so that nobody is confused. So the moments on RL, what is happening on RL? When you look at RL, you see, you will take every, okay, sorry, I'm forgetting to put a lot of important things here. So this will be just an arrow pointing upwards. Okay, so this is acting upwards. Also, this one is acting like that, and this force is acting downwards. This force is acting downwards, right? So to find out the moments acting on RL, we will look at RR because we are on RL, right? So we'll look at RR and we'll see what is happening at RR. What is the force in RR? Where is it going? So this is 4 meters, by the way. Okay, 4 meters, 4 meters. Right, guys. So we'll look at RR, right? We'll say moments. So what is happening? When you look at RR, you see that it is moving upwards. It is moving upwards. When you're standing over here on RR and you look across, you will see that it is moving upwards and it's going in an anti-clockwise direction, because if it's a circle, right, if it's something like this, it will be moving in an anti-clockwise direction. Do you see that? So it is moving in an anti-clockwise direction. So what you will say, guys, you will say sum of anti-clockwise moments is equal to sum of clockwise moments. Okay, is equal to sum of clockwise moments. And okay, now let me just do this. Let me just use this space. Is equal to sum of clockwise moments. Right, now you need to take your clockwise moments and your anti-clockwise moments. So what are your anti-clockwise moments? It's going to be RR. It will be R. Okay, now my writing all of a sudden is becoming very bad. Okay, let's just erase that, hide that, I mean. Okay, so anti-clockwise, hey guys, sorry. Okay, let me zoom out because I want you guys to see both that graph and this one. Okay, so what I have now, I'm going to look for anti-clockwise moments, right? Remember, this force is also acting in this direction, right? So I need to find the anti-clockwise moments. I'll see that I have RR, so I'll say RR. It'll be RR. So it'll be the force times the distance, RR times 4, right? RR times 4. What else do I have that is moving in an anti-clockwise direction? I have the 15 cos. Do you see this? This 15 cos, the horizontal the horizontal force. So I'll say plus 15 cos 60 degrees, right? And how did I explain how we got the 60 degrees, right? Now what's happening is that we need to multiply by the distance, and remember the distance is 0, so you can just say 0. Usually you don't have to write this. If you know what's happening, you don't have to write this, right? Is equal to, now let's find that. So are there any other forces that are going this way, right? So let's see, this one was going up, this one is going to the left, this one is going right, so we can't talk about that. Okay, so it's only that. Now let's move to the clockwise moments. When we look at the clockwise moments, we stand on this and then we try to find the moments that are going there, right? We're still on RR, right? So what do you see? You see that the 24 kilonewtons is moving down, right? So the 24 kilonewtons was already in the question, so you'll say 24 times, or you can even say 24 kilonewtons, like say 24 kilonewtons, okay? Right, 24 kilonewtons. Over here you can say 15 kilonewtons, it's fine, but I'm used to not putting the kilonewtons, so you can say 24 there. You will say your 24, but I think it's wiser for you to just say kilonewtons, right? So let's do that. 24 kilonewtons times the distance is acting after 2 meters, right? So times 2, right? Plus what else do we have? We have this horizontal. Oh no, we don't have. Before we get to the horizontal, we have the vertical member. Do you see? We have the vertical member of the wind load, which is 20 kilonewtons, right? Which I also indicated there as I indicated it. Okay, my writing is okay. I indicated it as 20 sine 30 degrees, right? 20 sine 30 degrees. Now we need to also add this one. Oh, sorry guys, sorry. Okay, no, it's fine. Sorry about that. Okay, what I'm saying is that you also need to multiply by the distance, right? That force you also have to multiply by the 2. Okay, you have to multiply by 2. Okay, and the next force that you have, plus this one here, the horizontal component, right? You will say, what is the horizontal component? Is 20 cos 30, but you will need to multiply it now with the distance, or the height. Sorry, you multiply it with the height. You have to multiply it with the height, and the height will be 2, 10, 30 degrees, right? Okay, so now we can solve for this. And how do we do that? Okay, it'd be easy. You can just put this entire side on the calculator, and then the right hand side, also the left hand side as well. Okay, the right hand side and the left hand side on the calculator. So this side, guys, what we will have on this side, we will have 4RR is equal to, I'm just noticing that I forgot another force. Okay, so before we do a calculation, I'm seeing that I forgot to add this force here that is acting downwards. So guys, yeah, you need to be careful, ne? I forgot to add this force that is acting downwards, the vertical component of the wind load. I forgot that, so you shouldn't forget that. Vertical component of the wind load, which will be plus 4 times, right, because it's acting 4 meters away, so 15 sine 60. Okay, 15 sine 60. Okay, I know this is not the best calculation, and now what you're supposed to get is 139.9615, and then if you divide both sides by 4, right, which you don't have to show in the exam, you can just say RR is equal to, right, so if you divide RR by 4, you get 34.99 kilonewtons. Okay, so this is your reaction, right? Okay guys, this is your reaction, right? So let me just say is equal to here, right, is equal to 34.99 kilonewtons. Kilonewtons. Okay, so that's how you do the first reaction, which is the reaction, right? Okay, you just need to get your load diagram correctly, right? So now let's move on to the following question. Now I'm going to erase this calculation. I'm going to erase this calculation and do moments at RL. So if you missed that, please, before I do that, okay, let me just zoom out to show you guys what happened, right? Let me just show you guys what happened, in case you want to check what happened, the numbers and everything. Okay, so now I'm going to erase this. Let me just do this fast. Okay, so that is how you find the reaction, right? Okay, so let's do the other reaction. So the other reaction is reaction L, or the hinge load, right? The reaction on the hinge. So we are going to look at RR. So we will stand on RR and look at the reaction RL, right? So guys, if you are learning something, like if you have learned something, I need you guys, if you're learning something from these videos, please don't be shy to comment, don't be shy to like, if you are learning something, so that I know that I'm actually helping, you guys to understand. It won't be nice for me to post and then you guys learn and you don't share a comment, or you don't tell me that you are improving. So I need that that support from you guys. Show me that you are learning, and you must subscribe, you have to like and comment, and show me that no, the content is actually helping a few people, so I don't end up just giving up and seeing that you people are learning, but then you are not liking and commenting and sharing and so forth. Okay guys, so now that we found the reaction right, now we need to find out reaction left. So for us to find out the reaction left, we need to stand on, for us to find out our reaction left, we will need to stand on RR, right? We will need to stand on our RR. And now what we'll say moments at RR, right? That is what we will say. We'll say moments at RR, and then we stand on RR and we look across and we see there's RL. But now I will say R, let me just say because this is it's a hinge, right? And it has a vertical and horizontal component, as I mentioned before. So we'll say a vertical component of what? Of RL, right? Of RL. You say a vertical component of RL, right? Or R hinge. RL is better. Okay, so what is happening with that? It is acting, but from here to here. Okay, before I say the vertical component, I need to find out what is happening when I look across. I see that from here, when I look that side, I am moving in a clockwise direction, and the RL is moving in a clockwise direction, right? So what I'll say sum of clockwise moments, right, is equal to anti-clockwise moments, right? Sum of clockwise moments is equal to sum of anti-clockwise moments. And now what I'll have to do, guys, is very simple. I'll have to go and look at RL. From RR, I look at RL, and I'll say, like I said, we'll name it vertical component. My goodness. We'll name it vertical component of what? Of RL, right? But now we multiply it by 4, isn't it? Now we need to add another force that is acting in this direction. Okay, from here, another force that is going there, right? That's what we need to do. Okay, so we will notice that we have the 20, we have the horizontal component of that force, which is the 20 cos, right? What is happening is that force is acting in the clockwise direction. So we'll say 20 cos 30 times 2 10 30 degrees. Okay, right? Because it is acting in which direction? It is acting in that direction. Okay, now that is the clockwise. Those are the forces that are acting in the clockwise direction, right? And equate it to the anti-clockwise moments, right? You will have to equate it to the anti-clockwise moments, and you will have to look at the forces that are acting in the anti-clockwise direction, right? When you stand on what? When you stand on RR. Guys, look at this. When you stand over here, you have to go like this. You see, the reason I took this force only was because it's moving in that direction. It's not doing what these forces are doing, coming down. These other forces are anti-clockwise because when you do this, they are coming here. It's stopping over here on the force. So it must not reach, you see, it mustn't stop on the force. It must pass the side that you have. Like it's coming from RR, it's passing RL and then going to stop. You see, it mustn't stop in between. Okay, you know what? When you look at this in this direction, you will see that it is moving in the anti-clockwise direction because it didn't come to RL. Okay, so just hope that you guys understand that. What I'm going to do now is to do the anti-clockwise. So when I'm over here and I look the other way around, right? When I look at the other way around, I see that I have sine, cos, I have 15 cos 60, but that one is is going to be multiplied by 0, so it does not count. But now I have the 24, right? I have the 24 kilonewtons, but I'll multiply that by 2 and add it. I'll have to add, right? Just give me a moment. Okay, I need to add, right? I will have to add the horizontal component as well. No, sorry, not the horizontal component. The vertical component of the 20. So I'll say plus 20 sine, it's 20 sine 30. It's 20 sine 30 times the distance, which is also 2. Okay, like that. And then I will have to find out what the answer is. So here I will have vertical component of reaction, the left reaction. What you will get is 68. You get 68 minus 20. Then you have to divide both sides by 4. And guys, you get CV RL will be equal to so your answer now would be, okay, so let me just do a quick calculation to find out what the answer would be. Right, so we are getting 12.02, right? 12.02 kilonewtons, right? 12 point but let's just say 12, right? Let's just say 12 kilonewtons. Okay, 12 kilonewtons for this one, right? So this is just the horizontal component. This is just the vertical component of your reaction. But now you need to find out the horizontal component as well. So how you will find the horizontal component is not very hard, right? To find your horizontal component, you will just have to say over here. So let me just do this. Let me write it here. So that's the vertical component. So the horizontal component, you just say horizontal for your horizontal component that you'll be looking for, you need to know that the sum of the horizontal components, so you say sum of horizontal components should be equal to 0. Therefore, you're going to take the horizontal component of the hinge. So you say horizontal component of RL is equal to, find the other forces that are acting in its direction. So you can see that you have this one here. You're looking for the horizontal component of the R hinge, right? So what you're going to do is you are going to find the other forces that are acting in that same direction and add. So you'll find out that you have 20, right? You have 20 cos 30, right? You have 20 cos 30 acting in that direction, isn't it? So that's the only force that you have that is going to the right. And then you're going to have to add it with you're going to have to equate it, to the other force that is opposing this, which is the 15 cos 60, right? 15 cos 60 degrees, right? Over here, for the horizontal components, you don't have to multiply with the distance, right? Because the R hinge, the distance is also 0, isn't it? The distance for the R hinge is 0, and then the distance for this, guys, is not important because you're working in the horizontal plane. Okay, so now we just need to calculate and find out what the horizontal component is. So horizontal component of the RL will be equal to if you punch that on the calculator, you're supposed to get a 9.8205, right? 9.8 is it? Okay, yeah, 205, right? So that is our horizontal component, right? So we have the vertical component, and we have the horizontal component, right? Guys, we are looking for the reaction of our hinge. So if we have a horizontal component and we have a vertical component, we can find the resultant. This is literally like grade 10, guys. Literally like grade 10. So how is it looking over there? It's going to be something like this, right? This will be the horizontal, and our vertical will be somewhere over here, isn't it? Our vertical component will be over here, right? Something like this. But I'm not going to show it like this now because we need our resultant. So I'm going to do it like this, right? So this would be our horizontal. Our horizontal will be 9.8205, and then our vertical will have to be 12 kilonewtons. Now we just need to find the hypotenuse, right? Remember, the hypotenuse is how you find your your resultant. The resultant will be the R hinge. Okay, the resultant would be the R hinge. So now let's just say R hinge now. R hinge will be equal to the vertical component squared plus the horizontal component squared. Do you see that? Now we just need to fill in. I'm just going to say 12 here. I don't know. Yeah, 12 kilonewtons plus the 9.805. But what I advise to put over here is to put an answer that is not rounded off, right? And guys, what we get for R hinge is going to be our R hinge would be now 15. Right, I get 15.5. I get 15.51, or you can even leave it to 3 decimal places. So I have 15.51. So this is the hypotenuse. So 15.51. But now I need to find the angle of this. I need to find out what the angle of this force is, right? I need to find out the angle of that force. So what do? I will say 10. That's 10 theta, because I'm solving for theta, and I'll just stand over here and look at the opposites and then the hypotenuse. So the opposite will be 12. The opposite will be 12, and the hypotenuse, the adjacent will be 9.8205. Okay, and then you get your theta, right? And your theta will be 50, right? Your theta will be 50, right? 50.70 degrees. So guys, this will be the direction at which the force is acting, right? This will be the direction in which the force is acting, and also that is how you do it. That is how you find out your reaction, right? So the reaction of the hinge. So the reaction of the hinge now will be the reaction of the hinge of your hinge. The reaction of your hinge will now be what we found out here. Sorry for this. The reaction of our hinge now, guys, will now be 15.51 kilonewtons. That will be the reaction, and its direction will be 50.7 degrees. You can say to the horizontal, since we have this here and our angle is on the horizontal, so you can say to the horizontal. All right, so guys, thank you guys for watching. Don't forget to share, like, comment, and subscribe if you're learning something from these videos. Yeah, and keep the community growing. If you have any requests, please don't forget, don't be shy. My WhatsApp link is in the description. Yes, right, so let's just go over this before I can say my goodbyes. Right, so guys, this is just this question. So what you had to do first was to transfer whatever that you were seeing in the diagram, right? You had to put it on your load diagram. You had to separate the vertical and the horizontal components, right? And then also you need to know, right, how to find your reactions, as in the direction, right? You need to have to know the anti-clockwise and the clockwise direction method. Thank you guys for watching. See you again in part 2. Cheers.